Let's go. It's Friday. All right. So, day 152. Man, how many days are left? 35 days until school's over. Whoa. Hope you're having a good day. Today is a really, really fun day of physics learning. So, really just getting to the basics. We've been doing some math stuff, learning about harmonics, but this is like the one day where things really get things that you use for your whole life or things that you experience for your whole life get explained. That's what sound is and what something called the Doppler effect is. So, I've got, make that pop up go away. Got a couple questions here for your warm up. One, have you ever noticed that an object moving towards you makes a different pitch sound than the same object moving away from you? And two, well, there's the answer. Why does that happen? Right? You may know that it's called the Doppler effect, but why? What is it about moving objects that changes the pitch of the sound emanating from that object? So make your best guess. And I'm back. And normally I would answer the warm up now, but I'm not gonna because, well, Mr. P is going to answer it here. So, for today, we're going to watch a few demonstrations, and I'm going to ask you to do something by Sunday, and that is to observe the Doppler effect somewhere, and then record it or write about it and explain what's going on. More about that later. So, I want to talk about Edpuzzle for a minute. We've been watching flipping physics videos for almost the entire year. I love flipping physics. Some of you do too. Some of you don't. But most of you feel like it's pretty good. And there's an issue with Edpuzzle that it ports the view of a video through its website, and in doing so filters all the demographic data away, and then. Buddy, I know you hear me talking. Yeah, I know. I can't play video games. Sorry. In doing so, it wipes away all the demographic video or all the demographic information from that view. YouTube lets people watch things for free because it's able to gather information about its viewers and then use those to target advertisements. Edpuzzle doesn't allow advertisements. So basically, any YouTube creator who puts their stuff or has their stuff viewed on Edpuzzle doesn't get credit for the views, doesn't get any comments, doesn't get to blow up, doesn't get any ad revenue. And Mr. P works 40% of the time as an in-class teacher and 60% of the time as a YouTube creator for flipping physics, which means he's trying to get a significant chunk of his revenue, his pay through his flipping physics business, and his videos are free. So if you're up for it today, watch the videos. Watch the videos on YouTube and then head on over to Edpuzzle and answer the questions, or watch the video on Edpuzzle and then maybe let the YouTube video play while you're taking a shower or taking a nap or whatever, and give them a like and a comment on YouTube. And if we don't support these things that are good and free, they go away. So something to keep in mind. Let's help him blow up a little bit. If you want more info on this, there's about a 4-minute video, because that's what he does, on Edpuzzle and how it all works right there. Okay, to the physics. So what is sound? This is a basic question, right? But what is it? Now that we've explored things like wavelength and amplitude and frequency and harmonics and nodes and antinodes and all these other things, all these technical terms, we've looked at waves a whole lot. What actually is sound? So normally in class, I teach this with speakers, and we look at the speakers and we watch them move, and we put stuff on the speakers like sand, and we watch it bounce, and we see the vibrations, and we walk around the room like I told you about the other day, and we find areas of constructive interference and destructive interference where it's loud and quiet, and we do all these explorations. Mr. P has found a way to show almost all of this stuff in a 12-minute video, which is amazing. I'm so impressed. So take a look at that. Here's a couple little snippets of what he's done. Remember, we used the tuning fork, or I showed you some tuning forks. A few of you actually had tuning forks, which is awesome. And check this out. Oop, wait, no, I don't want that. Play.
I can hear the tuning fork now. Often the sound waves, which spread out from a sound source like a tuning fork,
Ouch.
are represented by a ring of circles increasing in size. But what does this animation really represent? Circles are created by tuning forks?
And aren't there 2 tines on the fork creating circles?
Yes.
So shouldn't there be 2 sets of circles?
Yes.
Okay, there are 2 tines of the tuning fork.
All right, there's more. It's just like there's so much. It's so cool. I hope you watch and enjoy. And if you have questions that you ask. So that's the first chunk for today. So take some notes, do the Ed Puzzle questions. Here's the link to the actual YouTube video right here. Same deal here. Doppler effect. Why is it that sound is different for an approaching versus a retreating object? So this is what I'm talking about right here.
The Doppler effect is named after Christian Doppler, a 19th century mathematician and physicist who was able to mathematically describe what is now called the Doppler effect. And it sounds like this.
Well done. Perhaps you've heard that before. I'm sure you have. You've heard somebody honking as they drove past you. All right, it's a great example of the Doppler effect. You know, the horn is just the horn. It's not changing. The horn's not going from as it goes past you. It's not changing or anything. It's just the horn. If the car was just sitting there, it would sound like. So why is it? Right? Why does it sound like that? Trains sound like that when they go by. Trucks sound like that when they go by. Not just the horns, right? Just the noise of the vehicle itself. A jet flying overhead. All that stuff. All right. So maybe even like a skateboard as it skates by. I'm giving you ideas here for your later assignment. All right. So explore the Doppler effect. Look at the pictures. Look at the images where he shows the waves in front of a moving something and how, there it is, how they propagate, how they expand out from the moving object. So this is really cool stuff and it's the picture of the waves. See how they're compressed in the front and spread out in the back? All right. So that's the Doppler effect. So watch about that. Try and understand it. If you have questions, shoot me a note on the Remind app or via Schoology. So with that, I want you to try and document the Doppler effect. So instructions for how to do this are here, and you can upload your results onto Schoology. And then the last thing for today is a notebook check from this week. So make a PDF. Instructions for how to do that are here. And it's just, I put the days wrong. It's supposed to be 148 to 152. So just this week, 5 days. Shoot me that. I'll take a look at it. Next week, we do our last activity on sonic booms and bow waves. Bow waves come from boats and from planes. And then we're on to light waves and color. And that's it. Okay, so have a great weekend. Last thing. Don't be the guinea pig. Right? Some things are being relaxed this weekend. Don't be the first one, unless you have to. Right? Maybe some of your parents have to go to work. Maybe they're essential. That is what it is. But don't you go venturing out and hanging out with friends just because rules get relaxed a little bit. Sometimes these things snap back, and you don't want to be the one that gets to experience the snap back. Okay? All right. Miss you guys. See ya.